Arches and Lintels, Lesson 1. Traditional arches and lintels. Spanning items of openings are curved or horizontal load-bearing structures installed above a wall opening. They bear the load above the opening and transfers it to the supporting structure underneath. Lintels, straight-lined spanning structures of openings. The most ancient forms of lintels were made of wood or stone, either as simple beams or as a series of beams across the span. In structural terms, they are bent structures where the upper belt is subjected to compressive forces and the lower belt to tensile forces. Stone lintels. The tensile strength of stone is extremely low, so it is not economical as a bent structure. It means that spans of greater width can only be achieved with an exceptionally high structural height, which is not an economical solution. Timber lintels. In contrast, timber beams are considered highly efficient as bent structures, and therefore they have traditionally been the most commonly used straight-lined lintels. Timber lintels are square, cross-sectioned, hewn or sawn wooden beams laid in mortar or mud mortar on both sides of the opening, giving the lintel elements suitable bearing. For wider walls, several beams should be placed side by side, leaving ventilation gaps between them to prevent decay. Lintels were also exposed to extend their lifespan and were less frequently whitewashed, painted or timber-clad. Steel lintels. In the 19th century, additional materials appeared that performed the function of lintels economically. One is the steel beam, mainly built of I or U-section beams, or from their alignment. The beams must be bolted together at 1 meter intervals in the aligned arrangement. The required bearing width for steel beams is 1.5 to 2 times the beam height, typically placed in traditional small element brickwork. Under the beams, the bricks are placed in cement mortar or cast in concrete for structural reinforcement. Bricks are often placed between the steel beams with a protective coating over the beams. Alternatively, you can also plaster the beam with a mesh around it to protect the steel from corrosion. Also, the space around the beams can be filled with concrete by either shuttering the entire cross-section or forming a lintel casing. Aesthetically, it was particularly favourable to use a brick course of the same material as the brickwork, suspended on a steel wire fixed to the concrete back section. Arches. Curved spanning structures of openings. Arches are a special form of lintel originally constructed of stone or brick, using a wooden template to support the structure. Over the centuries, different forms of arches have evolved. What they all have in common is that they are subjected to a curved, compressive force at the supports, resulting in horizontal force components in addition to the vertical ones at the supports. Their origins are usually attributed to the Romans, who used the semicircular arch, also known as the round arch being the purest arch form, in a very versatile and widespread way. Stone arches. Stone arches were typically formed in stone walls. Roughly carved, slightly wedge-shaped natural stones can be used to create straight or semicircular arches over small openings. Precision-carved stones are required to form arches of any shape. Some examples include semicircular arches or round arches, segmental, three-centered, parabolic, rampant, three-pointed, acute round horseshoe, ogee, trefoil, or flat arches. Brick arches can be made in various shapes, using uniform or various reveal widths. The arches are built in a bonded manner, the same way as pillars. Typically, we use bricks without carving and with wedge-shaped mortar joints. However, large curvature arches with a small radius can only be masoned with wedge-shaped carved elements. In this case, joints with almost parallel sides are created between the wedge-shaped bricks. Arch masonry is only possible using templates. The bricks should be laid symmetrically from both sides of the impost until the two sides meet. The ribs should not be removed until the mortar has set. While a semicircular arch, round arch, can span 6 to 8 meters, the maximum span with a straight arch is only around 1.40 meters. The flat arch should be slightly curved with a rise of 2 to 4 centimeters to allow the structure to settle. Boards or planks should support the arch during construction. Flat arches can be made in two different designs. 1. Radial gap formation. 2. Parallel gap formation. In this case, the central part must be filled with wedge-shaped bricks,